So we learned how to integrate x to a power last week. So x to the 7th or x to the 1/2. We learned the simple power rule is we're going to raise the degree to from here from 7 to 8 and divide by 8 and add c. Or in a problem like this, we're going to raise the degree from 1/2 to 3/2 and divide by 3/2 and add c. But what we're going to talk about in the next couple of days is what do you do if it's not just x to a power? If it's some function to a power. The problem is that if it's a function to a power, we need to have a du, not a dx. And it would have to look like this. But if you look at this function, if u is x squared plus 6, du, or its derivative, du dx, is 2x. And so we're going to talk about the fact that without this 2x in the integral here or somewhere in the integral, we're not going to be able to integrate this and use the same rule we've been using, raise the degree and divide by the degree. Because if we tried it, we raised it to 8 and divided by 8, it's going to fail to give us this back because its derivative is going to be x squared plus 6 to the 7th times 2x. The chain rule is always going to come into play. And if the 2x isn't there, then our answer is not going to match. So we're not going to be able to integrate this when this is a function of x. It's not just x. And that's what we're going to talk about today. So we've got this general power rule that says if we have a function to a power and the derivative of that function is in the integral, then we can integrate it. And we do it by using a general power rule, raising the degree and dividing by that new degree, or raising the degree and multiplying by 1 over that new degree, whichever you prefer. But it's a big if. This du dx has to be in the integral. If it's not, you won't be able to integrate. So what it looks like in a problem is you're looking at an integral. The piece of the integral or the factor in the integral that has the highest degree is what you're going to say is your u. Just like we did when we were taking derivatives. We had to figure out what our u was and make sure we used the chain rule if we had to. So if this is u, x squared plus 4, then in the integral, we're integrating x squared plus 4 squared. If u is x squared plus 4, then the du dx that we want to make sure is in our integral is its derivative, which is 2x. And it's right there. 2x is in the integral. When we put 2x together with dx, it's like looking at this and just moving the dx to the other side. It's going to be du. So if we put du dx and then multiply it by dx, this thing will become du. And now all we're integrating is u squared du. If this letter matches that letter, then we can just use the simple power rule. It doesn't matter what the letter is, but if they match, all we have to do is take our u, raise its degree, divide by that new degree, and add c. And that is how the general power rule works. Once we get to the point where we're convinced that we have u to a power and we have du instead of dx, then we can use that power rule. Now, a lot of times people say, well, where did that 2x go? It just disappeared. And in fact, it really did disappear. It got sucked up with the dx to become this du that we needed. But you can see a little better if you check your answer. Check that this is the integral by taking its derivative. 3 times a third is 1. Then we're going to drop that degree of 3 down to 2 and use the chain rule. And we will have exactly what we started with. So the dx, remember, matched with the integral. They went together. But our answer should be right in between them, and it is. So the part of the integral that actually is allowing us to integrate with respect to u is going to disappear in our answer. So what you might want to do is try the rest of them on your own and then turn the video back on to check. Or if you want to go through them step by step with me, that's what I'm going to do. So I'm looking here and I see an x here, and this doesn't have an x. So this is definitely a higher degree. And I asked myself, if u were 5x plus 7, then what would du dx be? What is its derivative? And it's 5. So this 5 and this dx, if I put them together, they will be du. Because you can imagine, it's not technically like this, but you can imagine multiplying both sides by dx and saying that du is 5 times dx. So we're really integrating a function to a power with the correct differential. The variable matches that variable because the 5 and the dx together make that du. So now all we have to do is raise the degree on our u and divide by that new degree and add c. But you don't want to answer the question in terms of u if it was given in terms of x. So if you don't need to do this rewrite, if you just do it in your head and raise the degree on what you know to be u, which is 5x plus 7, and divide by that degree and add c. That's the better answer. But it's the same answer because you just could replace, do a substitution of the 5x plus 7 in there. Check your answer with the derivative. 4 times a fourth, drop the degree to 3 and multiply by the derivative of 5x plus 7. This matches what we started with. All right, again, if u is the one of these things that has the higher degree, so it's the 3x squared minus x, then its derivative is 6x minus 1. So it's set up to be able to be integrated. This is your du dx. You have your du dx, you have u to a power, and you have your differential. If you want to, you could rewrite it. So this would be one way to go, is to say, okay, then I'm going to rewrite this as u to the 6th du. Here's u, it's to the 6th, 6x minus 1, and dx gets sucked together to be du. So you can rewrite it like that. Then you can integrate it by raising the degree and dividing them by the degree and adding c. And then you can go ahead and put your 3x squared minus x back in for u. The other way to go is to just say, all right, I have a u to a power, I have the derivative I need there, so I'm just going to immediately raise the degree and divide by the degree on u. And instead of writing it down as u, keep it as 3x squared minus 7, 3x squared minus x. My check that this is the right answer. 7 times the 7th is 1. Keep this function the same. Drop the degree down to 6 and multiply on its derivative. And then you can check and make sure that what you had matches what you started with. For this one, my u would be the x cubed, not the x squared. Its derivative is 3x squared, so there it is right there. So I have my du dx. I have a u to the 1/2 power because it's in the square root. So if I rewrote it, I'm integrating u to the 1/2 du. And so I'm going to raise the degree to 3/2. I'm going to divide by 3/2, and I'm going to add c. And I'm doing all of that on u, so I'm doing all that on x cubed plus 4. The degree is going up to 3/2. I'm dividing by 3/2, and I'm adding c. And I can check. 3/2 times 2/3 is 1. This function doesn't change, but I drop its degree and I multiply on its derivative. This matches that. All right, so for e, it looks like a fraction, but we know it doesn't have to look like a fraction. We can use negative exponents to end up looking like this instead. Our u, in this case, would be the one with the higher degree. Its derivative is right here. So we have what we need in the integral. And what we're integrating is u to the -2 du. Because the -8x and the dx together are the du. So we're going to raise the degree to -1, divide by -1, and add c. And we're doing all that on what we set to be our u, which was 3 minus 4x squared. Can check it by -1 times -1 is 1. Don't change this function. Drop its degree down and multiply by its derivative. This matches that. And then finally, we've got 3/2 square root of x, so 3/2 x to the 1/2, and 4 plus x to the 3/2. So the higher degree is going to be our u. Its derivative is exactly what we have here. So we have the derivative we need here. We've got u to a second power and dx. So what we're integrating is u to the second power, and this together with that becomes our du. Going to raise the degree to 3. Going to divide by 3 and add c. And we're going to check our answer. 3 times 1/3 is 1. The function stays the same. The degree drops to 2. Multiply on 2x, derivative of 4 plus x to the 3/2, which is 3/2 x to the 1/2, which is what we started with. So it checks. So for all of those problems, we had the derivative that we needed in the integral, and we were just practicing what the general power rule looked like. What we're going to talk about next class is what to do if you don't have the derivative you need in the integral. How do you integrate that? What kind of things do you have to do? But this should be enough for you to get through that first homework assignment.